Good afternoon, class. Today we're going to be looking at circles, and we'll be graphing them using a very nice graphing tool that's built into Pearson MyLab. But the approach we're taking for circles is more of an algebraic approach. We make the assumption that y'all are familiar with what a circle is. Here's my XY grid. We make the assumption that y'all know what a circle looks like, which is a reasonable assumption, I believe, and that y'all know that a circle has a center, and it's defined to be the set of all points equidistant from a fixed point. Well, that's sort of a lopsided looking circle. And that equal distance all the way around is called the radius. So that distance right there is the radius. And in this example that I wrote, the circle is centered at the origin 0, 0. And am I right in saying y'all know what a circle is? This algebra of a circle, something y'all wouldn't know yet, but it's the set of all points that are equidistant from a fixed point. That fixed point is called the center. That distance from the center to the outer edge is called the radius. Let's suppose it's standard practice to denote the center of a circle using the ordered pair HK. So let's suppose that the center of a circle is at the ordered pair HK, and we'll use the letter lowercase r to represent the radius of a circle. We wrote equations of lines the last time in, I don't remember what number it was, but in the lines assignment we wrote equations of lines. Here we're going to write equations for circles, and we're going to use something called the center radius form. To write center radius form, you have to know the center, you have to know the radius. Center radius form parentheses squared there. Well, I'm running out of room, aren't I? Center radius form, it's x minus the x coordinate of the center, quantity squared, plus y minus the y coordinate of the center, which we're denoting as k, quantity squared, equals the radius square. That's a lot of letters, but realize x and y are the only things that are variables. That letter x is a variable. This letter y is a variable. All the other letters, h is a number, k is a number, and r is a number. So I'll say number, number, number. Okay, K and R and H are all numbers. And to get us started, remember, you still have to, even y'all are sitting here listening to this, so hopefully you won't have to listen through any of the videos here, and we can go directly and start clicking the questions. But if you don't click these things, you're not going to get credit for them, okay? So make sure, even if you don't need to watch the videos, you still got to click them to get credit. So looking at number 1, we want to find the center radius form of the equation of a circle with center at 0, 0 and radius 5. And then they want us to graph the circle. Let me write this problem down. Okay, so they tell us that the center of the circle is at 0, 0, and they tell us that the radius is 5. To write the center radius form of a circle, you need to know the center and the radius. They gave us that. So I'm going to denote H and K. In this case, H and K are the same number. What's H? What's my H value? 0. And letter H represents the x coordinate of the center. And what's K? 0 as well. And we know the radius, I wrote it out like that, r equals 5. So to write center radius form, we have x minus, I wasn't going to write that number there, x minus, I'm just writing out the part with the variables. Now I'm going to let y'all tell me well, I guess you can see there. Okay. Is it going to be one of those classes? Okay. Well, x minus the h value. H is 0, so I'll put the 0 there. I'll let y'all tell me what's going to go here. 0, the k value. And what's going to be squared here? 5. That radius gets squared. And we can clean this up very nicely. X minus 0 is just x. So we have an x squared plus y minus 0, that's just a y squared equals 5 squared is 25 for my center radius form. X squared plus y squared equals 25. Any questions there? Okay. I'm going to go. Okay, so we go back to my math lab and we click in the box. Have y'all typed exponents before now? I'm not sure y'all have had to type exponents. So type it in the center radius form for the equation. X, you come down here to the toolbar. Now, notice this little gray box with the blue box at the exponent position. If you hover over it, then you'll see what it says. It says superscript. Now, I'd like it better if they said exponent, but that's the box you'll use. You'll click there. Notice it gives you the little blue box up there for which you type your square. Is this what I want? Plus? Is that what I want? No, the plus is not in the exponent. So right arrow, click with your mouse, whatever you do to get out of that exponent position, plus y, superscript, square, get out of that exponent position before you type equals 25. And now we get to graph the circle. You have to know, back when I was in school, something like this would have just been science fiction, this little program graphing these circles. And if it existed, it would have cost literally hundreds of thousands of dollars. So it's amazing how technology changes. And we're going to have to choose the tool. We've used these graphing tools before. Which one do you think is going to be the circle tool? I think maybe the one that looks like the circle right there. It says, if you hover over it, it says circle tool. So, I guess I could do this. So it says to click the choose the tool, you choose the circle tool. The first thing they want you to do is plot the center. Now notice how tight it is there. So fortunately, remember, as you move your cursor around here above the little palette, the toolbar palette, we'll see the ordered pairs changing. We want 0, 0. Is that the center? Now they say they want you to plot a point on the circle. Well, how do we get a point on the circle? We don't have a point on the circle. Yes, we can figure out a point because we know the radius is 5. That means when you start at the center, if you move 5 units in any direction, you're going to get to that the edge of the circle. So let's move 5 units to the right. Notice as I move my mouse around, it's drawing in every possible circle with the center at 0, 0. So we want the one that has a radius of 5. So we'd have to go over. I'm moving 5 units to the right. Is that the point we want? 5, 0. You click it, save it, and then check your answer. Any questions there? Let's do one that's not centered at the origin. Those are the ones that are a little more interesting. So, number 2. Let me write it down. The center is at -3, 1, and the radius is 4. They tell us the center is at -3, +1, and the radius is 4. Right there. Okay, what number's acting like H? -3. The x-coordinate of the center is the H value. What number's acting like K? 1. So we have the parentheses x minus, I'll wait to fill in that space. The y minus, I'll wait, and a square. What's going to go after the x minus? The H value is -3. Good. What's going to go after the y minus? That +1. What's going to be squared here? 4. And this problem is going to illustrate something that's very important. What do we know about double negatives? X minus a -3. It'll be equal a +3. Correct. That minus a negative becomes a positive. Y minus 1, we'll just leave it as y minus 1. And on the right hand side we have 4 squared is 16. Here's the center radius form. And hopefully this illustrates something I'm about to say. If you know the center radius form, you can go backwards to get the center and the radius. If they gave you the equation, you can go back and determine the center and radius pretty easily. But the number inside the parentheses, the number you see, is exactly the opposite of the center. Look right there. I see a +3. Is the x-coordinate a +3? No, it's a -3. The minus from the formula combines with that negative on the 3 to give you a positive number. So what you see inside the parentheses is exactly the opposite of the center. You see a +3. The x-coordinate of the center is a -3. Here you see a -1. The y-coordinate of the center is a +1. Hey, if you have this r square over here, what do you do to go back to the radius? What undoes that squaring effect? A square root. So change sign, take the square root. And we will have some problems where the equation's in center radius form and you're having to go backwards. So let's type in our answers. Our answer. And left parenthesis, x plus 3, right parenthesis. I need the exponent key, they call it a superscript. It's flashing up there in the exponent position. I put the square. What do I do next? Okay, right arrow, click your mouse, what have you. Just get out of that exponent position. Plus, left parentheses, y minus 1. Do any of y'all use those key shortcuts? A shift up arrow gets you and does the same thing that the superscript button does. Square, right arrow, equals 16. Is that what I wanted to type? Yes. And now I'm going to draw the graph. This is better. The little tick marks aren't so packed in so tightly. So we click the circle graphing tool, and it's hard to distinguish colors on these projectors, but when I'm looking here at this screen up close, I can clearly tell the circle's drawn in gray, the center is blue, and then there's one extra point. That's saying you need the center and one extra point to use this tool. So we click the circle tool and we go to the center. What was the center? -3, 1. Is that the center I want? Yes. And now I need one other point. I need one other point. My radius is what? 4. What do y'all want to do? You want to move up 4 units? We're at 1. If we moved up 4 units on the y-axis, we're at 1 on the y-coordinate of 1. 1, 2, 3, 4. Is that where we want to be? Let's stop and look. Start counting from the center. 1, 2, 3, 4. If you count to the right, that's 4 units. Sure enough, that's what you want. Save it and check your answer. Any questions there? What you see inside the parentheses for center radius form is exactly the opposite of the center. And that will become important. But not yet. Here it's the same type of problem. They give us the center and the radius. So this is number 4. Number 4? Why did I do number 4? I thought I was going to do number 3. Let's do number 3 first. Okay, how did I get from number 2 to number 4? Did I click it twice? I must have. Okay, the center is at the ordered pair 4, -4, and the radius is 7. I'll switch over to my paper. Make sure I don't miscopy it. Okay, there. So, what number's acting like H? 4. What number's acting like K? -4. And my radius is 7. So I have X minus Y minus. What's going to go here? 4, the X coordinate. What'll go here? -4, the Y coordinate. Here. And then we can just clean it up a little bit. Generally, center radius form is the most desirable form for the equation of a circle. So if you're thinking, should we get rid of these parentheses? No, that's going to be one of the big problems as we go through this section. What happens when someone decides to expand this stuff, okay? But if it's up to you, leave it in center radius form. So you just have an x minus 4 squared plus a y. Okay, that minus a negative, that becomes a plus 4 quantity squared equals 7 squared is 49. Remember what I said. What you see inside the parentheses is exactly the opposite of the center. You see a -4, the x coordinate in the center. is a positive 4. Here you see a positive 4 with y. The y coordinate in the center is a negative 4. And hopefully you see why that's the case. Center radius form already has a minus. So when you stick on a negative coordinate, that becomes a positive number. Okay. Let's type that in. So left parenthesis x minus 4, shift up arrow square. I think that little shortcut is quicker than using the hot button. Y plus 4, shift up arrow square, equals 49. Is that what I wanted to type? Yes. Okay. And I still think it's better to pop it out. And I expand these instructions so it says to choose the tool. I'll give you a hint. In this assignment, the only tool you're going to be using is the circle tool, okay? That's the only shapes we're drawing in this assignment entitled circles. So we click the circle tool. What was the center? Realize something else. They could have asked you to draw the graph and then find the center radius form. You're not using the equation. When you're drawing this graph, you're not using the equation that you found. What are you using? You're using the center and the radius. So they could have told you, draw the graph and then find the equation. But going back. So the center was what? 4, negative 4. Oops, 4. Is that the center? Now we click it. And what's the radius? 7. So we're going to have to count 7 units, either up, down, left, or right. It doesn't matter. The way the thing moves, you'll still get the same graph. I think I'm going to count 7 units to the right. What's my x value here? 4 plus 7, so I'm going to 11. 1, 2, 3, 4, 5, 6, 7, 11, negative 4. Is that what I wanted? Yes. And notice if you stop and you count, it's 7 units up, 7 units to the left, 7 units down. You have to save it. You've got to transfer it back to the original grid. Check your answer. And here's number 4. Let me write it down. The center is at negative 2, 0, and the radius is 5. Oh, goodness. What number's acting like H? Okay, negative 2 is acting like H. What number's acting like K? 0. So we have x minus, y minus, and the square there. What's going to go after the x minus? Negative 2. What's going to go after the y minus? And what's being squared on the right? 5. I agree. X minus a negative. What's about to happen there? Okay, so we have an x plus 2 squared. We can clean this up very nicely. Y minus 0 squared is the same thing as just y squared. We don't even need parentheses there. Equals 25. Any questions on my logic? I should say any questions on my algebra. Okay. And left parentheses, x plus 2 squared plus y squared equals 25. Oh, by the way, realize I have the screen here on my computer blown up 150%. So if I didn't have it blown up the way I do, probably we wouldn't even have to use the little pop-out. Do y'all use the pop-out? Do you enlarge the graph when you do it, or do you just use the thing that's right beside it? So the reason mine looks like that is I have it enlarged 150% so that on the projectors around the classroom, it looks it's easier for you to see it. So we click the circle tool, we plot the center was, is that the point I wanted? So, and then the radius was how much? 5. Let's count up 5 units. So we're at 0, we're going up 5. Oops. Is that it? Yes. Save it. Saving it transfers it back to the original grid. Check answer. Pretty painless, right? Oh, that's not the same. Number 6. Number 5 is very similar to number 4, so we'll just go on to number 6. They give us an equation in center radius form. X minus 5 squared plus y plus 3 squared is equal to 4. And notice they tell us to graph the circle. Let me make sure I didn't miscopy this. Yes. There. They've already given us center radius form. To graph a circle, we need to know the center and the radius. I've told y'all what we're going to have to do. What do we do to find the actual center? What's the x-coordinate of the center going to be? Okay, change sign so that minus 5 you see there becomes a positive 5. What's the y-coordinate going to be? Negative 3. What's the radius going to be? You take the square root of that number, which gives you 2. Change sign, take the square root. They're little phrases I've said for 33 years of teaching this stuff, and that's one of them. Change sign, take the square root. One day I'll be in a nursing home, and I'll be in my rocking chair there in the nursing home, and I'll be saying these phrases. Change sign, take the square root. Those little I won't remember what I ate for breakfast, but you know what I'll remember? Change sign, take the square root. Oh, goodness. Let's draw the graph. Oh, goodness. There are other little phrases, especially when we get to logarithms, that I've said over and over for so many years. But I'm sure that'll be the things I'm saying as the people there at the nursing home will be like, oh, it's Mr. Precella. He's a bad dementia patient. Pay no attention to what he's saying. But I'll be saying, change sign, take the square root. So I click circle. Then the center we found was 5, negative 3. And the radius is 2. What direction do you want me to count? Up, down, left, or right? Let's count down. Let's just go down 2 units. 1, 2. I still think the way they make these points so big is really funny. I remember when the programmers did that, we had wanted bigger points. Teachers had said, oh, we'll make those points easier to see. Yeah, they did it. There. And check answer. Any questions there? There's number 7. Oh. This thing needs to be cleaned, the mouse, the way it's clicking twice when I'm clearly only clicking it once. So this is number 7. Same type of problem. X plus 2 quantity squared plus y plus 3 quantity squared is equal to 9. And the same instructions, they want us to draw the graph. As long as the equation is in center radius form, it's easy to determine the center and the radius. What's the center? Okay, I agree. Change sign, and then we take the square root of that number there to give us a radius of 3. Change sign, take the square root. As long as the equation is written in center radius form, it's easy to determine that center and radius. So we come over here, click, choose the circle tool, and the center is -2, -3. Is that what I want? And the radius was 3. How about we held up 3? We're down at -3 on the y-axis. If we go up 3, let's go down 3. I'm noticing there's all this stuff up above the center. Seems like counting down is neater. 1, 2, 3. Transfer it. There's the graph. Check answer. As long as the equation is written in center radius form, it's easy to determine the center and the radius. I'll want to, I think I'll work with number 6. I'm going to use that equation, okay? I want to consider this equation. Okay, thank you. I'm going to work with number 6 for the time being. It was x minus 5 quantity squared plus y plus 3 quantity squared is equal to 4. Suppose someone went through and removed all the parentheses. Well, x minus 5 squared, we know that's not just x squared and -5 squared. That's a binomial being squared. That means you have x minus 5 times x minus 5. What are we going to have to do to get rid of those parentheses? FOIL them out. We'll do that in a minute. Plus y plus 3 squared. That means you have y plus 3 times y plus 3. Let's FOIL out the stuff with the x minus 5s. First, x times x is x squared. Outer There's a point to all this stuff that I'm doing. Minus 5x, enter. Another minus 5x. And negative 5 times negative 5, that's a positive 25. Let's FOIL out the y plus 3 times the y plus 3. First, y squared, outer, okay, y times 3, I'll write as 3y, inner, another 3y, last, okay, 3 times 3, I agree with the plus 9. Let's suppose we decided to move this 4 over and get the thing set equal to 0. We would say minus 4 equals 0. We have some like terms here we can combine. We also have two different variables, x and y. Let's arrange the terms in descending order based on powers and put them alphabetical. X comes before y, so we'll have an x squared plus a y squared. Now let's combine the x terms. Negative 5x minus 5x gives us minus 10x, I agree. Let's combine the y's. We have 3y plus 3y plus 6y. And we have 25 plus 9, that's 34, minus 4, I'm getting a positive 30 equals 0. Center radius form is by far the nicest form for the equation of a circle. If you go through center radius form and remove all of the parentheses, the form you get, well, some people call it general form, some people call it expanded form. I like to call it expanded form. There's really nothing nice about expanded form. There. The thing we got there is expanded form. It's called expanded form. Can you just look there and determine the center and radius real easily? Up here on number 6, we were able to change sign. There's the center. Take the square root of that number. There's the radius. Can you do the same thing here? Is it easy to determine the center and the radius? That's the problem. That's what we're going to spend the rest of the class on. Suppose the equations are written in expanded form and you want to draw a graph of the circle. You're going to have to get it back in center radius form and then change sign, take the square root. Realize something like x minus 5 quantity squared. That's a perfect square trinomial. I should have combined those right off. Let's look at that x minus 5 quantity squared. We said that that's x minus 5 times x minus 5. And we FOILed that out. We got that x squared minus 5x plus 25. Minus 5x plus 25. We could combine those terms there to get an x squared minus 10x plus 25. Any trinomial that can be factored as a binomial squared, a binomial times itself, is called a perfect square trinomial. This thing here is a perfect square trinomial. I'm about to run out of room. I'm going to have to go to another page. We need to practice with perfect square trinomials because look at what's happening. Here's the general form that you want, but I don't even see a minus, well, I guess I do. I see the minus 10x right there, but in this form here, how do we go backwards to this factored form? I'm doing a bad job at saying what I'm trying to say. Let's just practice with some perfect square trinomials, okay? Perfect square trinomial. Yeah, I know what we'll do. I'm going to write up some perfect square trinomials. We're going to go backwards. I'll give the perfect square trinomial, and we'll figure out how to factor it. Here's one. X squared minus 14x plus 49. When you look at what we had right here, in the final answer, that per x minus 5 quantity squared, we picked up that 25. But the 25 is not appearing in the expanded form. You're going to have to break the constant into the constant you need for the x's, the constant you need for the y's, and then that number that's left over. So this thing, x squared minus 14x plus 49, let's factor it. First times first gives me x squared. There's only one possibility. What is it? X times x. We know something nice about the signs. And by the way, if it's a perfect square trinomial and it's going to factor us the same step, then this last number here will always have to be positive. So that number will always be positive if you're looking at a perfect square trinomial, and you'll have two of those first signs. So minus and minus. What times what's going to give us that 49? 7. So x squared minus 14x plus 49 factors as x minus 7 quantity squared. Okay, I have another one. The one that we were using a moment ago. Well, it's similar to it. X squared plus 10x plus 25. If the trinomial you're looking at is a perfect square trinomial, that constant has to be a perfect square. Is 25 a perfect square? Yes. How will that factor? X times x. What do we know about the signs? Okay, the last sign's a plus, so two of the first signs. What times what gives us 25? 5 and 5. So that becomes an x plus 5 quantity squared. This is the number that's going to be missing. In expanded form, those special numbers are the things that are wrong. Notice, once it's expanded, you have the x squared, you have the minus 10x, but I don't see that 25 appearing. You have the y squared plus 6y, I don't see the positive 9. So really, your goal is to figure out what number you're going to be writing in there to create a perfect square. So how about this one? X squared minus 6x plus what number? There's a pattern. There are two things we do to 10 to get to 25. There's two things you do to 14 to get to 49. Oh, thank you. Thanks. We're trying to figure out what number goes there. What do we do to 14 to come up with 49? Maybe it's more obvious. What can we do to 10 to get to 25? It's two things. Notice something. When you're factoring that 10, half of 10 is shown up there in the factorization. What's half of 14? 7. So it looks like that number in the parentheses is half of that number there. What do you do to that half number to get this constant? Square it. take half and square it. That's what's happening. Take half of 14, that's 7. 7 squared is 49. Take half of 10 is 5. 5 squared is 25. So what number we need to go here so that it'll factor as a binomial squared? Half of 6 is 3. 3 times 3 is 9. I agree. And then it's going to factor as what? X minus 3 quantity squared. Once you have the perfect square trinomial, it factors very nicely. It'll factor as variable, sign, that first sign, whatever that is, that'll be a minus, and then half of that number right there. Half of 6 was 3. What about this one? X squared plus 12x plus what? We're going to create a perfect square trinomial. What number needs to go into that blank so it factors as a binomial squared? Okay, I agree. Half of 12 is 6, and then 6 squared is 36. So you put the 36 here, and that's going to factor as variable, sign, here, 6. Half of that number. Variable, sign, half of the number. And remember, half of the things are going to have y's instead of x's. The pattern still follows. Oh no. How about a y squared minus 18x, not x. Y squared minus 18y plus something. What are we going to have to put there to create a perfect square in terms of y? Okay, you took half of 18. 18 divided by 2 is 9. You then square the 9 to get 81. So I agree with the 81. And then that's going to factor how? And you say, well, why do we want it factored as a binomial squared? Because that's center radius form. Remember, we're trying to get this stuff back to center radius form. So with that in mind, variable y, and then that sign there is a minus, so we put a minus. Half of 18 is 9. I agree. You take half of that coefficient of the unsquared variable and then square it. Half of 18 is 9. 9 squared is 81. And I have a good idea. I have something. When we're looking at center radius form, what will the coefficient of the variable in the parentheses always be? For center radius form, can we have like a 7 in front of that y? Center radius form is always just the variable itself. Just the variable itself. Well, let's see. Let's consider x squared minus 6x plus 9. Let's consider, this is a perfect square trinomial. X squared minus 6x plus 9. Suppose someone had gone through and multiplied everything by 2. Then what would be the coefficient of x there? 2x squared minus 12x plus 18. That is undesirable. If you have a number in front of your x squared, for this pattern to work making perfect square trinomials, that number in front of x squared must be a 1. So if you have any number there other than 1, you're going to have to divide through everything by that number. And you'll see what I mean in a little bit. Let's try Let's try number 9. Putting together our skill, remember, you go to the unsquared variable, you take half of it and square it. That's the number you use to create the perfect square trinomial. So, number 8. The instructions say find the center and radius of the circle and then draw the graph. Well, those are the same instructions we were using for numbers 7 and 6 and 5, but they were real easy because the previous ones, when they were having you find this, draw the graph, you need the center and the radius, they were already in center radius form. So your goal, when you see something like that, your goal is to get the equation written in center radius form. I've been talking, I wasn't writing. I better write down the equation. X squared plus y squared minus 14x plus 4y is equal to 28. There, let me make sure. There. So they want us to find the center and radius and in order to do that we need to get it into center radius form. So here's your goal. I'm going to write the goal down here, okay? Your goal is, oh, it isn't. Thank you. There, thank you. I'm just looking here, seeing everything so clearly. Okay, but no, thank you. I didn't have the projectors showing. So your goal is you want your parentheses with your x squared plus your parentheses with your y squared, and over here you want a number. That's the goal. You're trying to create perfect square trinomials for x and then perfect square trinomials for y. Group the x terms together. You have an x squared minus 14x. X squared minus 14x plus, skip some space. We're going to add a number in there to create a perfect square. Now the y terms. So plus, we have y squared, a plus 4y, plus, skip some space. In most cases, they have the constant over on the left-hand side, and you have to move it over to the right-hand side. For this first one, they've got the constant on the right-hand side for us. That's nice. I'll just say equals 28. We're trying to create a perfect square trinomial. Remember the little pattern we were using. How do we come up with 9? How do we come up with 36? You look at the coefficient of the unsquared variable, and you have to do two things to it. The coefficient of that unsquared variable is, well, technically it's a negative 14, but the sign doesn't matter here. 14, we do two things. What is it? Take half of it. So 14, here's my scratch work. 14 divided by 2 is 7. Then what do I do with the 7? Square it. 7 squared is 49. So we're going to put plus 49 right there. But a moment ago when we were playing around with this stuff, we didn't have an equation. We were just working building trinomials. But with an equation, if you add 49 pounds to one side of the scale to maintain the balance, you better add 49 pounds to the other side as well. So, whatever number you put in that blank, you better add it to the other side. And once again, that number you're adding will always be positive, because when you square the number, the result will be positive. And while we're thinking of these x terms, let's factor. Remember we had a pattern. Perfect square trinomials, they factor variable, sine, half of that number. So variable, sine, what number's going to go here? Half of 14 is 7. I agree. What are we going to add for the y's? We want to create a perfect square trinomial. What are we going to add for the y's? Okay, go through the steps. Half of 4 is 2. 2 squared is 4. So we add 4 here. But remember, those equals are like a scale. You added 4 pounds to one side, you better add 4 pounds to the other side to maintain the balance. How will the y terms factor? Okay, variable, sine, half of that number, I agree with 2. Quantity squared. What have we got on the right? 28 plus 49 plus 4. 28 plus 4 is 32. 32 plus 50 is... well, I'd say minus, it was 82 and then minus 1 is an 81. I think this is... I didn't need to write this down so low. We didn't need all that room. Look at that. I think we got it in center radius form. There's the x binomial squared. Here's the y binomial squared. And we have a number over here on the right-hand side. Now, so what do we do to get the center? Change sign, and here, take the square root. That brings up an important point. I said we had to have a number over here. We can be more specific. We have to have a positive number over here. You can't wind up with a negative number on the right-hand side, because when you take the square root of a negative number is imaginary. So we could say that our goal is to have a positive number. If it's a circle, you're going to have a positive number. But what was the center? 7, negative 2. And the radius? And that's all we need in order to draw the graph. This process of creating perfect square trinomials is called completing the square. Back when we were solving quadratic equations, I said there's another method that we can use to solve quadratic equations called completing the square. We'd see that when we got to circles. Well, we're at circles now. This process of creating those perfect, really of figuring out that number there and that number and factoring it as binomial squares, that is called completing the square. Once we know the center and the radius, that's one of those things though. And y'all know my rules, my laws. If I woke up and ruled the world, the first thing would be I'd eliminate y variables from math class. We'd have to use like an x and a w, because I don't like those curly tails. They get down there and they mess up the line. I have to leave a lot of space because the curly tails interfere with what I'm trying to write. Another one would be, unless you're looking at implicit differentiation in a calculus class, I would outlaw this expanded form. Taking center radius form and expanding it, I'd outlaw it. Then guess what? You would never have to go through all of this stuff, learning to complete the square to write it in center radius form. Does that sound like a good law? To me it does. Make things a lot easier. Oh, goodness. Oh, goodness. Okay, so I'll collect my circle. The center is at 7, negative 2. Oh, be careful. They're incrementing in units of 2. That's not what I want. Is that it? Is that the center I want? Yes. And so I'm going to have to move 9 units if I'm at 7. 7 plus 9. 7 plus 9, wouldn't that be 16, negative 2? Is that it? Click. Save. Once again, there's the grid. There's the original graph that I transferred it back to. Any questions? Group the x terms together, skip some space. Group the y terms together, skip some space. Then perform those steps, taking half of the unsquared variable and take half of the unsquared variable and square the result. Same type of problem, number 9. Before we do that, I'm going to make some observations. I said it a moment ago, but for center radius form, this number must be positive. It must be positive if it's going to be a circle. If this number is positive, it is a circle. You're looking at a circle. Suppose you had it, your center radius form on the left, and you wound up with a negative number. If this number over here is negative, when you try to take the square root of a negative number, what sort of a number is that? Imaginary. That means there's no graph whatsoever. There's no graph. If the number on the right-hand side of center radius form winds up being negative, then you're not going to have a graph. Suppose you get your center radius form on the left and you get a 0 on the right. What's the square root of 0? 0. So you locate your center, but how many units up, down, left, right do you move? There is a graph. It's just a center point. All you would have. If the number on the right winds up being a 0, your graph is the center point. And these special cases do pop up. If the number on the right is positive, great, you have a circle. If the number on the right is negative, you have nothing. I guess you'd have an imaginary graph. If the number on the right is 0, your graph is just the point. You can locate the center point, but you don't go up, down, left, or right. Let's do number 9. Well, any questions? I said there was messy algebra in here. So number 9. Same instructions. They want us to graph the circle. That means we need the center and the radius. Let me write the equation down. X squared plus y squared minus 4x plus 2y minus 31 is equal to 0. In order to draw the graph, we have to find the center and radius. And to find the center and radius, we've got to get it in center radius form. So we'll group our x terms together. X squared minus 4x plus, we're going to add a number there. We'll get our y terms together. That's a y squared plus 2y plus, skip some space. Let's move the constant term over to the right to give us equals a positive 31. What number are we going to add in to the blue blank right there. I couldn't hear you. Half of 4 is 2. 2 squared is 4. I agree. Half of 4 is 2. 2 squared is 4. And if we add the 4 here, we're going to have to add the 4 over here to maintain the equality. What number will we add into the y blank? 1, I agree. Half of 2 is 1. Here's my scratch work. Half of 2 is 1, and 1 squared is 1. So we add 1 to the left side and 1 to the right side. The x side factors very nicely. How will the x terms factor? Variable, sine, half of that number, x minus 2, I agree, quantity squared, plus. I couldn't hear you. Y plus 1, variable, sine, half of that number, equals 36. That's one thing. This number over here could be something that's not a perfect square, like a 35. But remember, using the graphing tool, the way you have to move out that many units. If that were a square root of 35, that'd be a 5.8 something or another. Well, how would you count that exact number? So that's one nice thing with the graphing tools. They're going to make sure that the r square is a perfect square. What's the center? 2, negative 1. What's the radius? You take the square root of 36, which is 6. Any questions there? So we come over here. Click our circle tool. The center is at 2, negative 1. Is that 2, negative 1? Yes. And let's move down 6 units. So 1, 2, 3, 4, 5, 6. We've got negative 1. We move down 6. So we're at negative 7. Is that where we want to be? Yes. But notice, if you move up, you would be at positive 5. You can move right, left, it doesn't matter. Just choose a distance and move that's easy for you to count, easy for you to tell as you're graphing. And there it is, checking it. Number 10. There is something that is very wrong with this equation. Hey, they don't want us to draw the graph, though. They just want us to find the center and the radius. They're even giving us an option. I mean, they're giving it to us as multiple choice. But there is something very, very wrong with this equation. And I tried to allude to that earlier. We're going to have to write this equation in center radius form. Let me make sure I have this problem written down correctly. Remember, our goal is the parentheses x squared plus the parentheses y squared equals hopefully a positive number on the right hand side. But there's something wrong here. the little process we use to complete the square, to build those perfect squares. And remember, what's the coefficient supposed to be inside those parentheses? If you have a leading coefficient of anything other than 1, you must divide through by that number so that the coefficients for x squared and y squared become a positive 1. Divide through by 2. Basically, we're distributing a 1/2 through the entire equation. We're multiplying both sides by 1/2. Then that's going to give us 1x squared plus 1y squared plus 20 divided by 2 is 10x plus 12 divided by 2 is 6y plus 50 divided by 2 is 25 equals 0 divided by 2 stays 0. And now this problem, the way we got rid of those leading coefficients, it looks like number 9, doesn't it? You have x squared, y squared, xy number. X squared, y squared, xy number. So let's group our x terms together. We have x squared. Where's the next x term? The plus 10x plus skip space plus, we have a y squared. What else? Plus 6y plus skip some space. What are we going to do with that 25? Move it over so it's a negative 25. Don't start saying, oh, it's going to be imaginary, because we still have to add on the red number and the green number. So plus the red number. I'm going to put these little blanks there so I don't forget to add them to both sides. What number is going to go in the red blank? Half of 10 is 5. 5 times 5 is 25. So we're adding 25 to both sides. Any questions on our logic there? What are we going to add into the green blank? Half of 6 is 3. 6 divided by 2 is 3. 3 times 3 is 9. So add 9 to both sides. Let's factor the trinomials that we built. Factoring the red trinomial, the x trinomial. What do we have in the parentheses? What did you say? X sine half of 10. I agree. Variable sine half of that number. X plus 5 squared plus y plus 3. I agree. Variable sine half of that number. What have we got on the right hand side? Negative 25 plus 25 plus 9. That works out nicely. Yeah, negative 25 plus 25 is 0 plus 9. Gives me a constant of 9. Is this going to be a circle? Yes, because that number over there is positive. What's the center? Negative 5, negative 3. Change sign, radius. Take the square root of 9, which is 3. Change sign, take the square root. If your equation has a leading coefficient other than 1, you're going to have to divide through by that before you do anything else. Why? Because if you have a 2 there, that means this thing right here should have some number other than just a 1. Because x times x isn't going to give you a 2x squared. It's going to give you just an x squared. center radius form, the coefficient for x is 1. That means the coefficient for x squared in expanded form needs to be a 1. So -5, -3, radius of 3. Oh, we don't have to graph this. I remember this was a multiple choice. A, B, C, or D? D, I agree. Okay, how about number 11? Decide whether or not the equation has a circle as its graph. If it does, give the center and radius. If it doesn't, describe the graph. This is the stuff I was talking about, referring to earlier. Look at what these options are. Well, let me write the problem down first. Okay. Special cases of center radius form. I was mentioning that back over here. That looks like such a mess. If you have center radius form, x minus h quantity squared plus y minus k quantity squared equals r squared. If this thing is positive, you're looking at a circle. If the number on the right-hand side turns out to be 0, you're looking just at a center point. You can label the center point, but you can't go up, down, left, or right. So if it's 0, you're looking, I think all they want is just a point. If that thing turns out to be negative, you're taking the square root of a negative number. If the right-hand side turns out to be negative, there is no graph. I guess it's just an imaginary graph you can imagine up in your head somewhere on some other plane of existence. And I think they have a fourth condition there, don't they? What is it? The graph, look, sounding fancy. The graph is non-existent. That would be what I'm calling no graph, okay? The thing where I wrote no graph, I guess I'd say non-existent. Non-existent. I prefer if they just said no graph. But what are they? Wait a minute. The graph of the equation is a line. Do lines have x squares and y squares? You certainly shouldn't be choosing that. Make a note that a line has no x squared or y squared. Only x's and y's, as we saw in that previous homework assignment. These instructions could make you think, decide whether or not the equation has a circle as its graph. It makes it sound like you can just look there and decide. No, you're going to have to write it in center radius form. I'd like it better if they said, write the equation in center radius form, then decide whether the equation has a circle as its graph. So we're looking at number 11. Let me make sure I didn't miscopy it. Yeah, okay. Coming down. Let's write this in center radius form. What's my leading coefficient? Well, the number in front of x squared, I don't see a number, so it's assumed to be 1. So we don't have to divide by anything. Remember in that previous one, where was it? Where we had leading coefficients for x squared and y squared of 2, we had to divide by 2. But here, it's already in the desired form, x squared and y squared. Let's group the x terms together. X squared plus 8x plus, skip some space. Group the y terms together. Y squared plus 4y plus, skip some space. What am I going to do with the 19? Move it over, make it a negative 19. And realize you're going to have a blue blank and a black blank on the right side too. What number is going to go beside the x squared plus 8x? Okay, 8 divided by 2 is 4. 4 times 4 is 16. So I put the 16 there. I move over and put the 16. What's going to go beside the y squared plus 4y? Okay, half of 4 is 2. 4 divided by 2 is 2. 2 times 2, we get back to 4. So put 4 in the black blanks. Let's factor. Let's factor the x terms. What have I got in the parentheses? I'll get us started. X plus 4, I agree. There's a pattern. Variable, sign, half of that number. That's another one of those phrases that I'll be saying there as I'm sitting in the rocking chair, at the nursing home. Variable, sign, half of the number. Change sign, take the square root. And they'll be like, oh, that's Mr. Precella. He just rambles. What's going to go in the parentheses for the y's? Variable, sign, half of the number. Hey, what have we got on the right-hand side? That's a 20. 16 plus 4 is 20. Negative 19 plus 20, that's a positive number. So we do have a circle. What's the center? Okay, change sign. What's the radius? We take the square root of 1, which is still just a 1. So we have a circle centered at -4, -2, and a radius of 1. A circle, which one is that? A, B, C, or D? It's certainly not A, the equation being a point. Here it is. We enter in the center. You have to type in ordered pair, parentheses, -4, comma, -2, right parenthesis, and the radius is 1. Any questions there? You still have to complete the square on the x's and the y's to get the equation in center radius form before you can decide if the equation represents a circle or not. What about number 12? X squared plus y squared plus 2x minus 6y plus 19 is equal to 0. And it's the same instructions. Decide if it's a circle. If it's a circle, state the center and radius. If it's not a circle, describe what sort of graph we're looking at. Okay, y'all tell me what to do. What do you think I'm going to do first? Group. Okay, I'm going to group the x terms together. X squared plus 2x plus skip some space. Group the y terms together. That's a plus y squared minus 6y plus skip some space. What am I going to do with the 19? Move it over, making it a negative 19. I have a blue blank and a black blank. What's going to go in the blue blank? Half of 2 is 1. 1 squared is 1. What's going to go in the black blank? In this one here, the number you add is always going to be positive. Oh, I see what you mean, okay? You mean this number over here is going to be negative. That's what you're saying. I was talking about in this number right here, what are we going to add? Half of 6 is 3. 3 squared is 9. Oh, I should have written that in black. Everything looks black on the screen anyway, doesn't it, there? I think you're right. What's about to happen over here? What are we going to get? A negative 9. We're not going to have a graph, are we? Trying to take the square root of negative 9. I'm going to go ahead. I think we need to go ahead and practice factoring our perfect squares. So I know the graph isn't going to exist. There's no graph. But let's go ahead and still, I feel like the problem's incomplete if we don't factor that. So just humor me. What would the x parentheses be? What would be inside it? X plus 1 quantity squared plus, now the y parentheses, y minus 3 equals a negative 9. When you try to take the square root of negative 9, you get an imaginary number. So there is no graph. So you come over to problem number 12. And once again, they're not saying there is no graph. They're trying to be fancy. The graph is non-existent. I think they wanted every sentence to begin with the graph. That's why they would say something so silly. It's non-existent. Any questions there? Number 13, same type of problem. We're not graphing it. Just decide if it's a graph, and if it's if it's not a graph, describe it. This is number 13. X squared plus y squared minus 6x minus 8y plus 25 is equal to 0. X squared plus, I don't like this. X squared plus y squared minus. Okay, this is the last problem with circles. Number 14 is probably a cut point problem. I think it's a cut point problem. So this is the last problem. What will I do first? Group. I'll group the x squared plus, no, it's a minus 6x plus blank. Then I'll group the y terms, y squared minus 8y plus blank. What am I doing with the 25? Move it over, give me a negative 25 plus blue blank plus black blank. What am I going to put in the blue blank? Okay, 6 divided by 2 is 3. 3 times 3 is 9. I agree. So, what am I going to put here beside the y squared minus 8y? 16. 8 divided by 2 is 4. 4 times 4 is 16. What have we got on the right-hand side? Negative 25 plus 9 plus 16. I think we're getting a 0. That means that the graph is just going to be a point. Let's go ahead and factor these terms here. Let's factor the x group. What will I have inside these parentheses? X minus 3, variable, sign, half of that number. What am I going to have in the y parentheses? Y minus 4. What would the center be? 3, 4, but when you try to take the square root of this number, that's when you get a radius of 0. All you have is the center point. That graph would have the center point 3, 4. If you plug in 3 for x, you get 0 squared, plus plug in 4 for y, you get another 0 squared. 0 squared plus 0 squared is equal to 0. So the graph is just a point, but we can be more specific. It's not just any point. The graph is the center point. All you would have is a dot at 3, 4, and that's it. Any questions there? But all they want you to say is that the graph is a point. Any questions there? Oh, this went quicker than I thought it would. Did I skip any? Let's see. Hey, we skipped number 5. What was that? Why did we skip number 5? Oh, well, this seems pretty easy now, doesn't it? Okay. Find the center radius form of the equation of the circle. Has a center at the point 0, negative 2. And the radius is 4. Okay, it's number 5. What number's acting like H? 0. What number's acting like K? Negative 2. We have x minus, we have y minus, and we have a square. So what did you say goes after the x minus here? 0 here. And what's being squared here? 4. And we can clean this up very nicely. X minus 0 is just x. So we have x squared plus y minus a negative 2. That becomes a y plus 2. And what have we got on the right side? 16. And they want us to type that answer in. So, x squared plus y plus 2 squared equals 16. Is that what I wanted to type? Yes. Now, click my circle tool. The center was at 0, -2. Is that the point I want? Yes. And then the radius was what? 4. So we'll go down 4. 1, 2, 3, 4. We were at -2. We went down 4. We're at -6. Yeah, that looks right to me. And here it is. Any questions? Hold on. Well, look at that. I didn't do 14 and 15, but still I only have a 65. What have I not done? You have to click on them even if you're not watching them. I wonder, when was this video made? October 3rd of last year. Oh, it looks like that's my writing there, isn't it? Okay. So Tony's making a habit of missing the circles lecture on Here I go. Okay. You know something? Before we go, I'm still recording on it. Okay, I'm still recording. Stop this.